In this video lecture, we will discuss about the diffusion process and the current which arises due to the diffusion process in semiconductor. In semiconductor, transport of charge may be accounted by a mechanism called diffusion and which is not ordinarily encountered in metal. So it is possible to have non-uniform concentration in semiconductor, and this non-uniform concentration of hole or electrons result in diffusion current responsible by either by holes or electrons. The concentration of holes or electron varies with distance x in a semiconductor. The holes or electron will always move from higher concentration to lower concentration till a equilibrium condition arises. Suppose dP upon dx represent the whole concentration gradient and dN upon dx represent the electron concentration gradient. So due to this non-uniform concentration of carrier in semiconductor, a diffusion current arises that is represented by Jp for holes, and it is given by Jp equal to minus of Q dP upon dx, where dP is diffusion constant for holes, and in this case we assume that P decreases with increasing x, so we choose dP upon dx as a negative, so a negative sign arises. Similarly for electron, the diffusion current because of electron is given by Jn equal to Q dN upon dN upon dx, where again dN equal to the diffusion constant for electron. The P is replaced by M and the minus sign is replaced by positive sign. So equation number 1 and 2 give the mathematical expression for current density due to hole concentration gradient and due to electron concentration gradient. Now we will see the Einstein relation. Here a diffusion constant dP and dN is defined, and diffusion and mobility are independent, and the relation between them is called Einstein relationship. So dP upon mu p equal to dN upon mu n equal to Vt. So this relation is called Einstein relation, where Vt is defined as the volt equivalent of temperature, and it is defined as Vt equal to K bar T upon Q, and where K is the reduced Boltzmann constant, Q is charge of electrons. If we put the value of K and Q, then this relation is given as T upon 11,600. So Vt is dependent on T. So if we calculate the value of volts equivalent Vt at room temperature, that at T equal to 300 degree Kelvin, Vt is given as 0.026 volt. So if we know the value of Vt and the value of mu p, mobility constant or diffusion constant, then we can find out the remaining parameter. Now if we want to calculate the total current density due to diffusion and drift, or we can say that it is possible to have potential as well as concentration gradient within a semiconductor. So in this case, the total current is a summation of drift and diffusion current. So the total current because of holes is given by Jp and equal to drift current plus diffusion current. And the drift current is given as Q mu P E, and the diffusion current is calculated in equation first. Jp equal to minus of q dp upon dx, minus of q dp upon dx. Similarly, the net electron current is Jn equal to q mu n plus q dn upon dx. So these are the two important relations we find out. The current in semiconductor due to hole and the current in semiconductor due to electrons. So we saw that in semiconductor two phenomena can be available or can be responsible for current. One is drift and the second one is diffusion current, and the expression due to hole and electron is given by equation A and equation B.